Okay, so for number 7, we are making, again, the left side look like the right side. You could take this and make it into sines and cosines. That is an option. Only reason I'm not is for 2 things. Number 1, I look at my right-hand side, and it's not in terms of sines and cosines, so it's not going to be a natural progression. The other thing is, I see that this is squared. So if I just start to work with the left-hand side, I'll show you my thought in a second. So I would have 1 minus tangent of x, if I expand this out, times 1 minus tangent of x. Okay, which means we could do that double distribution or FOIL. So if I were to FOIL this out, 1 times 1, we get 1. My outside terms, I get negative tangent of x. My inside terms, I get negative tangent of x. So that's going to leave me with negative 2 tangent of x. My last terms would give me positive tangent squared x. Okay, remember, only working with the left to make it look like the right. So I'm just going to shuffle properties around for a second here, meaning I'm going to rearrange this. I have 1 plus tangent squared x minus 2 tangent of x. Why did I do that? Well, because I'm noticing right here, minus 2 tangent of x is this part that I want for my final answer. Okay, so now all I have is 1 plus tangent squared of x. And we're going to go back to your Pythagorean identities. And we know the basic ones. Okay, so we know sine squared plus cosine squared is equal to 1. All right, we have the other ones. How do I get the other ones? How do I get the one with tangent? Well, if I took this and if I divided this by cosine, divide everything through by cosine, and simplify. So sine squared divided by cosine squared, that's tangent squared. Cosine squared divided by cosine squared, there's 1. 1 divided by cosine squared, that's going to be secant squared. So now look at what we just found. We found a substitution for 1 plus tangent squared x. That's secant squared x. That's what we wanted. So we have secant squared x minus 2 tangent x, and that's number 7.